Today I will give you a presentation about basic logic gates. It's a basic concept in computer science. As you know, all digital equipment is constructing using a few basic circuits like this. You can see this is a chip inside any computer, and there is a lot of circuit inside this chips. We want to know how inside this chip, how the data are represented. Do you know what is the form of data stored inside computers? Can you repeat? What, how the data are stored, in which form? Inside the memory of computer.
It's motherboard. Hard drive.
Yeah, we store it like this. This is the data exactly inside the computer. It's all 0 and 1s. And this is called a Boolean number because it has only two values, 0 or 1, on or off, as in the electricity on or off, high or low. So the gates are the basic logical circuit. As I say, it's maybe high or low, 1 or off, 1 or 0, 2 or false. This is exactly how we store the data inside any computer. And we deal with this number to make the operation and to make anything inside the computer and make it work. There is an input and output for any gates. The input means the data we enter to this circuit, and the output is the data which we get after enter the circuit. We will see the truth table, which are used to help to show the function of logical gates. I will show you this later. There are mainly 6 gates: AND, OR, not NAND, NOR, XOR, and XNOR. We will see each of these, and we will take an exercise after that. Okay, this is the first gate, AND gate. It's an electronic circuit that gives a high output only if all its input are high. These are the two input, and this is the output. We represent this circuit by this shape, and we can call the result of this circuit A dot B or AB. So we want to see the truth table of this circuit. I can put here A and B. And here is the result, A and B. We will have 4 choices, possible choices. A may be 0 and B 0. A could be also 0 and B here 1, because we only have two numbers, 2 values. And here if A 1, B will 0, and if A 1, B will be 1. This is all possible choices for this input. What is the output? As we say here, it gives a high output. It means 1 only if all its input are high. If all its input are high, this is high and this is high. So we will get 1. High output. So we will get here 1. And all the rest we will get 0. This is AND gate. Easy.
Yes.
Do you understand? Okay, we will see the next gate. This is the truth table. The next one is OR gate, which is an electronic circuit that gives a high output 1 if one or more of its input are high. We can represent the output A plus B. This is the output, and this is the shape of OR gate. So we have the same as this, but here we will have this. What is the result? Can one guess from this? We will get 1 if one or more of input are high.
0, 1, 1, 1.
Yeah. 0, 1, 1, 1. Clear? Because we have 1 here. If one or more, and 1 here, and here we have 1 and 1. So the result here is like this. Clear?
Yeah.
This is the truth table. The next one is not gate. This is an inverter, because if we have 0, we will get 1. If we get 1, we will get 0. The opposite. We usually represent this by this circle and this shape. So this is the nut. If we have A, we will get A like this. There is a dash above the A. This
The
is
opposite.
the result. Yeah. If we have here 0, we will get 1. If we got 1, we will get 0. This is the truth table. We have also the NAND gate, which is not AND, the same as AND gate, which we have it in the first, but this is the opposite. As you see here, the shape is the same as AND gate, but we put this to make it the opposite, the inverter. So, do you remember what AND gate was? AND gate was like this. You remember that?
Yeah.
AND gate. NAND gate, we will get what? We will get like this, A, B, but we have like this. And what we have, the inverter, 1, 1, 1, 0. This is the result of NAND gate, because it is the same as AND, but we put this to make it the opposite. This is the truth table. This is NOR gate, which is mean no, not OR gate. This is OR gate, we have it here. It's shaped like OR gate, but we put this inverter here. Let's write it on. Do you remember what A plus B was? You say it. 0, 1, 1, 1. So for this A plus B, we will get 1, 0, 0, 0. This is the result, because it's the same as NOR gate. Okay. The next gate is the XOR gate, exclusive OR. This gate will give a high output. A high output mean 1 if either, but not both of its 2 input are high. Who knows what is this? This is the XOR gate. It's like OR gate, but we put this here, and we represent it like this: A plus B by this. We can get one with either, but not both. Either of one, this is either. Of them is high, so we will get here 1, 1, and we will get here 0, because this is both.
If we have two similar numbers.
Yeah, if we have two similar opposite number, we will get it like this. This is the XOR gate. gates. It's exclusive NOR. It's the opposite of the XOR gate which we take it. So if you want to write it, we'll write it. It's 1, 2, 3. Is it clear? We put this inverter here to make it the opposite of XOR. This is XOR. This is the truth table. And this is the summary of all gates. You can see them here. And we will do now an interesting example to see if we understand those or not. And this is the truth table. We will take this one, this circuit. This is a bigger circuit. We represent, this is, do you know this one? Or. No, not or.
No.
This is not. And this is? And this is?
Nor.
Or. So, we want to use this table to see how we can solve this one and get the number here. So let's write it here. So if we, here A will come here, what will happen to A? It will be A dash. Let's write it. So here, A after what is the output of A after not gate? It will be like this.
A dash.
Dash.
That means the opposite.
Yeah, this is the opposite. And this is B. This is after it will come here, it will be B boost. And here A, it also come here. And here B, come here. Okay? And this is what? AND gate. What is the result of this?
A dash B.
A dash B. And this one? A
B dash.
B dash. And after these two input come here, what is the result?
A dash B.
A dash B
Add. Plus.
plus
A.
A B dash. Easy?
Yeah.
Yeah, this is the operation. So we will make the truth table to see what is the result. So if we will take all these possibilities. So if here 0, it will be 1. 0, let's assume that this is 0 and this is 0. Here it will be 1. And here B come here. And here B will be 1. And A 0. So 1 and 0 in AND gate. What will give? You can look to it. This is AND gate.
0.
0. And here 0 and 1 in AND gate.
0.
0. And 0 and 0 in OR gate.
0.
1. So this is the result of the first one. Okay, can we make this 0, and this is 1. So here,
1,
1, and here, 0.
0,
And here B,
1,
1, and here,
0,
0. 1 and 1 in the AND gate,
1,
1. And 0 and 0 in AND gate,
0,
0. What is the result of OR?
0, 1, 1.
1, 1. So we will get 1. Okay. Does it make sense?
yeah.
Okay, here 1 and here 0. So 1 will be 0, and here A 1. B here will
0,
0, and here
1,
1. So 0 and 0, 0. And 1 and 1 in AND gate,
1,
1. 1 and 0,
1.
1. One here,
0,
0, and here 1. And here 1, 0. 1 and 0,
1.
1.
0.
0.
And 1 and 0, 0. 0 and 0. This is 4. 0 and 0,
0.
0. This one is wrong here. We make it wrong. So we will try it again. Here 0 and here 0. A 1, 0. And here B 0. And here is 1. 1 and 0. In the AND gate.
0.
0,
0. And here the same 0 and 1 in AND gate, 0. And 0 and 0 in OR, so will be 0 and 1.
yeah.
So this is the result of this circuit. Interesting. Okay, this is the result, and this is the result of the. And this result, can you tell me it's the same as which gate? It's like XOR, if you see in the paper. In the XOR gate have the same result. So by this equation, we will get the result of XOR gate. We will take another exercise.
No.
Will we make it?
No.
I'm kidding. This is just an example for a complex circuit inside the computer, because inside the computer we have the circuit like this and more complex circuit. This is maybe done one operation like this for equation. So these are the references. You can see more information here. And this is all. Thank you for listening.